right? This is the robot, right? And this is the obstacle, it's a point, right? So if you put, let's say that you, as you said, right, you said that always it should be greater than 90 degrees. That is not exactly needed, right? Let's say that the obstacle is a point, right? If you generate uh, 5 degrees, right, then it can avoid the obstacle. See, if you go 0 degree angle, it will hit the obstacle, but if you can make it to 5 degrees, right, it can avoid the point object. If it is a wall, yes, it will hit, but if it is a point object or a small object which is not like a wall, right, it can avoid the that obstacle, right?
That means in level 1, we just need to get a number to avoid the obstacle, or we have to get the most suitable, that means optimized number for the angle.
You need to get the most optimized number. Yes, that's what we are doing with the vector addition, right? Because the next task is, right, to move through some barrier objects, to move this robot through some barrier objects. In that case, you need to you cannot definitely you cannot simply use this Wander effect to calculate random direction and move like that. You need to consider all the field forces coming, all the forces, right, coming from these obstacles, right? That's what sir has discussed in here. Yeah, stayed in the middle using potential field methodology, right? You can calculate the potential field, and yeah, so that is something else to discuss. Okay, that will be discussed in the next practical. So anyway, you need to calculate all the field forces from all the objects, right? Otherwise we cannot move the car through those barriers. Yeah, that's the thing. Right. Okay, try to find a way to generate a random value, right? Just search how to generate random values in Python, MicroPython, and get a random value, convert that to an angle in between 0 to 360, right? And then consider the front side as the main vector, right? And create a vector opposite to that direction, because you know that if you move towards that direction, it will definitely hit the wall, right? So you need to definitely inverse the vector to convert to change the vector in the opposite direction, and use that. Give me 1 second. Right, so as I said, you need to take that vector, right, which is directed away from the obstacle, and consider the other vector that you got from the random value, right? Get the vector summation and turn the robot into that direction. That's what you have to do in the task.
So how do we get like represent a vector in the code?
Think. You don't have to specifically, represent a vector.
Oh.
Right? Not in that form, not in vector form, right? Definitely no need to do that. But however, when you're writing the code, it should, show us, it should clearly show us that you are considering the vector direction. So there is no specific way to to do this coding, right? It may be different from one to another, right? But the idea is that, right, you need to, if you have written a code, um, following all the things that I said to you, right, then that's going to be okay, right? No need to define vectors, okay, do like that you are doing in real mathematics, right? No need to do like that. But anyway, it should follow those things that I have discussed here, right? Okay, I will give you a little time to think, right? In the meantime, if you don't, okay, let's say that you need to find something that you don't know, you can just search it in the Google to get some, um, not the entire solution, right? To find how to generate a random number in MicroPython, you can search those things in the internet, right? And then try to come up with a solution for this problem. And if you come up with a problem for this problem, right, you can send it to me so I can um, use that coding to demonstrate the behavior, right? Were you able to do something? or you're still trying on it. Right. So, are you guys there? Because I'm going to explain another thing.
Yes, sir, I have tried some code,
Okay.
but I am not sure whether the thing the needed is this.
Mhm.
I just do is generate the angle
Okay.
within -1